malware researcher in Vinh Cybersecurity. I'm here today to represent for example SPECTRALVIPER, which is a highly sophisticated malware targeting Vietnam financial sector. First, let me start by my presentation. I will introduce the malware and explain why this malware is interesting. Next, I will walk through the exchange and deep dive into technical analysis, especially focused on string obfuscation, digital communication, and comparative threat with other written one. Finally, we will wrap up some key takeaways, including the detection insight. So, what is the SPECTRALVIPER? SPECTRALVIPER was first discovered in June 2023 by the Atlantic Security. This malware primarily targeted the Vietnam public company and private user. The tracker will link in APT32, which is a famous APT group in Vietnam. To maximize this impact, the malware often used alongside with payload for reels or power shield. So why this malware is interesting? First, this malware is distinguished in several ways. First, the malware during the exchange, there's no use any conventional loader or example, which make the signature is harder. Second, the persistent malware kind of unique. By embedding itself within the previously installed program, the malware looks especially less suspicious to the user and the AV scanner or EDR. Like another malware, this malware also hides the string indicator by the obfuscation string, but the routine for the decryption is kind of unique, which makes the malware stand out. And finally, this malware share the same attribute with the SPECTRALVIPER variant, and they have the evolution during the time. So now we come to the exchange. Here is the most common exchange we found and examine this incident. Attacker will first drop multiple payloads, including the login file in the previous installed program, then create a task schedule to trigger that login to load the payload. Once the payload is loaded into memory, it's both hooked into the free library API which manipulate the execution when any library free up memory will ultimately lead to execute the malicious behavior. Here example, by using the Microsoft Silent Binaries OC, which already masquerade to the VFC update, for example, and drop into the previous installed program, the malware will use the execute command to load the payload. Here, the load command, you can see the malware use the VC update with the masqueraded OC and the log DLL with the payload. And especially can be seen that sometimes the location for the malware is unique and it can be used for decrypting information. In another case, composite technique implement, malware attacker also drop the multiple malicious into previous installed program like before. But in this case, instead of using the vulnerability technique, the malware will use the composite technique to execute the malware. Here it is. The composite technique is implemented by the modified improve server 22 to load the payload which is dropped before the task schedule will trigger the core object. An interesting part is that instead of just one payload, now malware is split into the multiple one. The main deal payload is dropped will be executed by will trigger by the core object. We will delay import the import from the second binary. The second one will import several helper function from the third. But another thing we can see that even in the delay import directory, the extension is .dll. But when it's the incident, the extension instead of DLL is .log.xml, which is not the normal looking for. So how this can be loaded into the memory? Yeah, another clever tactic was implemented by attacker. They use the fact that the Microsoft VC loader allow user to use their own loader, custom loader, instead of the load library API to load the DLL, the delay of DLL. They implement their own loader, which is a manual loader, perform tasks like allocate memories, mapping the DLL into memories, and resolve API, and relocation, which will lead to the load the malware secretly into memory and also hide the handle of this malware from the security scan tool, which serves as an elegant evasion technique. Now the experience come to the end, we will shift focus into a technical analysis. Now shifting focus into the string encryption. You will see that the first 4 bytes is the struct of the string encryption. The first 4 bytes will stand for the input, the length of the string encryption. The 16 4 bytes, the first byte include the string length will hold the data block, and the big block here is the encrypted block. So how this can be decryption? The malware will implement the advanced encryption standard with ECB mode to encrypt the data block with a hardcode key that derives the first byte of the encrypted block. Use this as a short key for the encrypted string, and for the remaining part of the encryption, the algorithm stays the same, but the data block will change by emit the first byte and append the trailing byte with either decrypted byte before the encrypted byte, but the just previous decrypted before. To automatically extract all the string, we also implement some Python script. The Python script is kind of straightforward by implementing find the reference to the file reference to the encrypted string, locate the encrypted, then apply the algorithm we analyzed before. And when we decrypt all the string, this reveals a lot of interesting information input during the execution. C2, even the C2 can be seen in the encrypted string. We will shed light into the true malware capability and objective. Now we come to C2 communication. Here it is. As I mentioned before, sometimes C2 URL appear in the decrypted string, but it's not all the case. It's not always. Here is the case. The C2 decrypt will be encoded with the source, and the key for the source encryption is the location of the payload, which will show the strong record of the attacker. Now in the C2 data flow, this is how malware can communicate to the attacker. First, attacker will encrypt the data block with the algorithm, the same method decryption before I mentioned. Then we will encode with base 64, then send with the key. L can send B2 to attacker will send the payload and do the reverse process. Then finally we will validate with SA1 host to validate in the E tab of the header. The malware implements several C2 commands. We support a lot of range, about 40 commands. The command includes process injection, system monitoring, even with the file manipulation, and with token manipulation for escalator evasion. And finally, it can also map impersonate other user in the local system. We give the attacker comprehensive toolkit to manipulate the compromised system. Now we come to comparison. The similarity, the decryption and encryption string algorithm for the string obfuscation is the same for every sample we found in the wild. Even the hardcode key for them is the same. About the differences, there are evolution during the time. For the previous sample, we can see that the C2YL hardcode in the decrypted string, but for now is encoded with source key, and with key the key of the system compromises. about the target of injection process. Instead of the suspicious running 32 is now changed into the SDLL code with less suspicious about the AIS key. For example, for every sample, different from per sample. This key is used for C2 payload encryption sent to server is different. Now about the C2 command. Compared to the previous sample outlined by the analytic security, the command 2 and 3 we use for download file and upload file will now update into the reading message from the file and the reading message, writing message to the file instead. And the command 200, instead of running the old process, is now hooked into the create thread to run the shellcode. About some key takeaway, I want to send you the first is the Java rule for detection. We use the fact that the malware had to create the UUID used for C2 encryption key and the obfuscation routine. We found that is unique, for example. Here the TTP, the malware is unique for this malware. This malware is first stealthy by implement command technique, LOLBAS, and abuse the MFBC loader ping mechanism. This malware also serves as an adaptive by providing comprehensive toolkit for C2 commission, and this malware also can be very dangerous by the C2 by the string obfuscation. This finally make this malware stand out for us. And we also set IOC for detection. Also, you can see. For reference, for anyone want to learn more about this is some reference we use during the analysis the malware. If you have any question, we can stop now. Thank you.